welcome to the deep dive. Today, we're focusing on something you probably see almost every day, but maybe don't give the proper respect it deserves.
The railroad crossing.
Exactly. These are places that are so easy to underestimate, yet they're some of the most dangerous spots on our entire road network.
They really are.
So this deep dive is going to be your necessary shortcut to understanding the critical safety knowledge you need.
That's absolutely the mission. Collisions at crossings are statistically rare, but when they happen, they're catastrophic.
Right.
So our job is to go beyond just the warning signs and really distill the practical intelligence from our source material. We're going to cover the physics, the signal mechanics, and maybe most importantly, those split-second emergency procedures.
Procedures that can literally separate survival from tragedy.
No question.
So for you listening, our goal is to answer three huge questions. First, why does a train seem to defy the normal rules of physics when it comes to stopping? Second, how do the signals actually detect a train that might be minutes away?
That's the fascinating part.
And third, what is the single, very counterintuitive, life-saving thing you have to do if your car stalls right on the tracks? Okay, let's start with the basics. The inherent danger, we all know a train is big, but I think the actual physical reality of a collision is something our brains just don't process well.
It's a scale issue. It really is. It all comes down to momentum and this concept of long stopping distances.
Long stopping distance.
Yeah. I mean, we're talking about inertia on a scale that's, well, it's almost unimaginable.
Give us the numbers.
Okay, so a typical freight train, right? Say 6,000 tons moving at 55 miles an hour, it needs over a mile.
A mile to stop.
Over a mile, sometimes up to a mile and a half, to come to a full, complete stop. And that's what the emergency brakes slammed on.
That's just incredible. I mean, in a car, you slam on the brakes, you're stopping in, 150 feet?
Precisely. So if a locomotive engineer sees your vehicle on the tracks a quarter mile away, the outcome, it's already been decided.
They're basically just a witness at that point.
That's a harsh way to put it, but it's true. They are powerless to stop. That reality is why all the safety responsibility has to fall on the motorist or the pedestrian.
But it's not just the train's momentum, right? The actual environment around the crossing can be actively working against you.
Oh, absolutely. Let's talk about obstructed views.
The things you just don't see coming.
Exactly. It could be anything. Dense trees, a big building right up against the tracks, or, and this is a big one, another train parked on a nearby track that completely hides the one that's actually moving.
So by the time you can actually see around the obstruction to check if it's clear,
You're already in the danger zone. You're too close.
And then there's the danger of multiple tracks. I think everyone has felt this. The first train goes by, the gates go up, and your first instinct is just go.
That is probably the deadliest moment at a multi-track crossing. It's sometimes called the second train surprise.
The second train surprise. I like that.
Because the sound and the sight of that first train can completely mask a second one coming from the other direction.
Right, and you're impatient, you think the system is done, the lights are still flashing, but you just go for it.
And you drive directly into the path of the other train. It happens way too often.
And what about just, bad weather? Fog, snow, darkness.
They compound everything. First, obviously, they reduce your visibility. But second, snow and ice, they reduce your car's ability to stop before the tracks.
So you might slide into the crossing even if you see the train.
You could.
Yeah.
And when you combine any of that with human factors,
Yeah.
Being in a rush, being distracted by your phone,
Yeah.
the margin for error just becomes zero. It's completely gone.
So if physics makes the train unstoppable and the environment can hide the danger, then we really have to understand the technology that's designed to warn us.
Exactly. It's our only line of defense.
Let's get into that infrastructure then. Not all crossings are the same. You've got two main categories, starting with the most basic one.
Right. You have passive crossings and active crossings.
Passive first, what does that mean?
It means the crossing relies only on static signs. There's nothing automated. You'll see the cross buck, it's the white X sign, maybe a stop or a yield sign, and the RXR painted on the road.
And that's it. The rest is up to you.
It's 100% on the driver to stop, look, and listen.
And then you have the active crossings, which are the ones we're probably more familiar with in cities.
Correct. Those are the ones with the automated warning devices. The flashing red lights, the bells, and of course the gates that come down and physically block the road.
They actively tell you there's a problem.
They scream it at you, yeah.
Okay, so this is the part that I think is really cool. How does that active system actually know a train is coming? Especially somewhere remote. What's the secret?
Well, the primary method and it's been used for over 100 years because it's just so reliable, is the track circuit.
Jack circuit. Okay.
Think of the rails themselves as part of a giant, very simple electrical circuit. There's a low-voltage current running through them.
So the rails are electrified.
In a very minor way, yes. Now, the wheels and the axle of a train are made of conductive metal.
Ah, I think I see where this is going.
When the train's wheels and axle hit that section of track, they connect the two rails. They basically create a short circuit, or what engineers call a shunt.
So the train itself completes the circuit.
It changes the electrical resistance, and the system detects that change instantly. That's the trigger. That tells the system a train is here, and it starts the whole warning sequence.
Wow. So the train is the sensor.
The train is the sensor. It's brilliant in its simplicity. It doesn't rely on cameras or lasers. It relies on the fundamental physical presence of the train.
It sounds almost foolproof. Are there any weaknesses?
Well, its reliability is its strength. But, for instance, if the power to the circuit fails, the system is designed to fail safe, meaning the gates will come down and the lights will flash even if there's no train. It defaults to the safest possible state.
Okay, that makes sense. A false alarm is better than no alarm.
Exactly. And sometimes really heavy rust or leaves on the tracks can interfere with the conductivity, but that's a maintenance issue they work hard to prevent.
Let's talk about the timing. From the moment I hear that first bell, how much time do I actually have?
It's designed to be very generous. Federal rules require enough warning time for the biggest, slowest truck to safely clear the crossing. In general, the signals activate, maybe a couple of minutes before the train gets there.
So it feels like a long time, but it's for a reason.
It's for the worst-case vehicle. And you're right about the sequence, too. The bells almost always start a few seconds before the lights start flashing. It's that initial auditory cue.
And just for context, you also have the best-case scenario, the grade-separated crossings.
Right, your overpasses and underpasses. They're the gold standard because they completely eliminate the point of conflict. No chance of a collision.
And what about quiet zones? I hear about those a lot.
Yeah, those are usually in residential areas where the routine use of the train horn is restricted. To make up for that lost warning, the crossings have to have extra safety measures.
Like what?
Like gates that block all four quadrants of the road so you can't drive around them. Or special medians, it's a trade-off. Less noise for more physical barriers.
Okay, so knowing all this, let's get into the practical, actionable rules. Rule number 1 feels obvious, but I see people break it all the time. Obey all warning devices.
It's pure negligence not to. When those gates are down, it means a train is coming. Or the system thinks a train is coming. Either way, you do not go around them. Ever.
It's not a suggestion.
It is an absolute command.
Rule number 2 is more about planning, especially in traffic. Never stop on the tracks.
This is such a critical one for city driving. You have to look at the other side of the crossing before you start to cross.
And make sure there's room for your whole car.
Your whole car plus a safety buffer. You have to imagine the traffic in front of you stopping dead. Would your rear bumper still be over the rails? If the answer is maybe, you wait. Don't start crossing.
Because getting trapped there is a completely avoidable situation.
Completely. It just takes discipline.
And Rule 3 applies to everyone, drivers and pedestrians. Stay alert.
Put the phone away. If you're walking, take your headphones out. You need all of your senses.
Especially when visibility is bad, like in fog or heavy rain.
Absolutely. In those conditions, you need to slow way down. And here's a huge practical tip. Open your windows.
Turn the radio down and open the windows.
Yeah, you need to listen. You might hear the horn or the rumble of the train on the rails long before your eyes can pick it up through the fog.
Okay, now for the scenario most of us have no idea how to handle.
Yeah.
A signal malfunction. The gates are down, lights are flashing, you've been waiting 5 minutes, and there is no train in sight.
Right. The first, most important rule is do not cross. You have to assume the system is working correctly and a train is coming, even if you can't see it.
Okay, so I'm stuck. Now what?
Now, your job is to find the blue emergency notification system sign, the ENS sign.
That little blue sign, I've seen them.
They're posted right there at the crossing, usually on the signal mast or a nearby pole. It is your direct communication link to the railroad itself.
Bypassing 911?
Initially, yes, because the railroad dispatcher is the only one who can directly contact the trains.
Yeah.
The sign has 2 critical pieces of information on it.
Which are?
A phone number for the railroad's dispatch center. And, this is the most important part, a unique crossing ID number.
That number identifies this exact spot on the map for them.
Instantly. out of thousands of miles of track. You call, you give them that ID number, and you tell them the gates are down with no train. They can then warn any approaching trains and send a maintenance crew. It's the fastest, safest way to resolve it.
Okay, we've done prevention, we've done malfunctions. Let's tackle the absolute worst case scenario. Your car stalls on the tracks, mechanical failure, whatever. What is the one non-negotiable, immediate priority?
Evacuate immediately.
Don't even try to restart it.
Do not waste a single second trying to restart the car. Get out. Get everyone out. Get away from the vehicle and away from the tracks. It doesn't matter if you see a train or not. Time is everything.
Okay, so you're out of the car. Now, the direction you run is critical, and this is the part that is so deeply counterintuitive.
It is. Once you're clear, you need to move away from the tracks at about a 45-degree angle. But, and this is the key, you run toward the direction of the oncoming train.
Wait, you want me to run toward the train, the thing that's about to destroy my car? That sounds completely insane.
It sounds insane, but it's pure physics. Think about the impact.
Okay.
When that locomotive hits your car, all that metal, plastic, glass, the engine block, it's going to be launched outward and forward in the same direction the train is traveling.
It creates a debris field.
A massive cone of shrapnel. If the train is heading north, the debris is going to fly north and out to the east and west.
Ah, so by running toward the train at that 45-degree angle,
You are running out of the path of that flying debris. You're putting yourself in the safest possible spot. If you run away from the train in the same direction it's traveling, you could be running right into the middle of the debris field.
wow, that is a piece of information that could genuinely save your life.
It's the difference between surviving the incident and being killed by the shrapnel from your own vehicle.
So once you and everyone else are safely clear out of that debris path, what's next?
Once you are safe, and only then, you find that ENS sign again.
The blue sign.
Call the number, give them that crossing ID immediately. They can alert any approaching trains. They might be far enough away to actually begin emergency braking and, lessen the impact or even stop.
And we should just briefly mention, a car can stall for weird reasons on tracks, right? It's not always the engine.
That's true. Sometimes the high profile of the tracks can cause a low car to get stuck, what they call high-centered. And very rarely, the intense vibration can trip a sensor in some older cars. But really, the reason doesn't matter. The response is always the same.
Get out, get away.
Get out, get away, run toward the train.
This has been an incredibly important deep dive. Let's just try to consolidate the absolute core takeaways for everyone. First, respect the physics. The long stopping distances mean the train cannot and will not stop for you.
Second, understand the warnings. Know the difference between a passive and an active crossing, and trust that the track circuit technology is telling you the truth long before you can see anything.
And third, master that emergency plan. If you stall, you evacuate immediately. You move away from the tracks at a 45-degree angle toward the approaching train.
And you use that ENS crossing ID to alert the railroad. The margin for error here is just. It's zero. Your vigilance has to go beyond what your eyes can see. You have to respect the gates and the lights, always.
So to leave you with a final thought, we spent a lot of time talking about really sophisticated systems, track circuits, emergency notification signs, and the hard physics of it all. Yet almost every problem we identified came back to a breakdown in human discipline. Ignoring gates, not planning for traffic, panicking.
That's right.
So here's the question to think about. Given that the most common dangers come from us misjudging time and distance, how does all this amazing technology actually shift the main safety challenge? Is it less about the detection of the train now and more about the simple human discipline required to believe and use the safety information that's being handed to you?
Something to think about.
Think about that next time you see those flashing lights.
Please like, subscribe, and get notified.